In this video, we are going to be learning how to track our significant figures through calculations. This is part of our learning objective for recording measurements and calculations using the correct number of significant figures. We have two rules for tracking our significant figures through calculations. One is for multiplication and division, since those are inverse operations. And then we have a second significant figure rule for addition and subtraction, since those are also inverse operations, meaning they undo each other. So if we are multiplying these two numbers together, then the multiplication rule says that our answer should have the same number of significant figures as the quantity with the fewest significant figures. So if we count how many sig figs are in each number, this number has 3 significant figures, 1, 2, 3. This number has 2 significant figures, and so 2 is less than 3, and so our answer should have 2 significant figures. Remember, you start counting at the leftmost non-zero digit, and then you count towards the right. Then we apply our rounding rule, and that 2 tells us that we should round down, and then we would report our answer as 0.91. The same would go for division. You just look at how many there are. 2 is less than 3. Keep 2 sig figs. The addition and subtraction rule is different. Rather than looking at the counts of sig figs, we are looking at the precision of each number. The more digits to the right there are, the more precise the number is. But your answer should only be precise to the same decimal place as the least precise quantity. So I have several examples here to help demonstrate how this rule is different than the multiplication and division rule. We have to find the least precise decimal place. In this first example, both numbers are larger than 1. So we have to think for larger numbers. Each of these is a different place in the number. It's not like how many digits after the decimal are there, it's which decimal place is least precise. So in this first number, this 0 at the end is not significant because there's no decimal point written. This is just a placeholder. So the last significant digit in this number is in the tens place. This one is significant to the ones place. Tens is less precise than ones because this tells us that we at least know it within 1. This tells us we only know it within 10. And so this is a smaller increment. And so our answer can only be precise to the tens place. Sometimes you might find it useful to kind of draw a dotted line down to show you that the ones should not be there. You would look at the 9 and round up, and then you could report your answer as 120,230. Or you could write it in scientific notation, 1.2023, without the 0 at the end because that 0 is not significant. And then you go times 10 to the 1, 2, 3, 4, 5. Times 10 to the 5th. Either way is okay. For our next example, we are adding 2 digits that do have digits after the decimal point. And so we have to figure out which place each of these is in. The 9 here is the most precise number in this one. And so this 9 is in the tens, hundredths, thousandths place. And this 8 is in the 10th place. And so if this is your decimal point, the farther this way you are, the more precise the number is. So the 10th place is less precise than the thousandths place. And so our answer should only be significant to the 10th place. And so imaginary line down, look at the 0, 0 rounds down, 2.0. Now we have this number with the 10.09, 2.09. This 9 here is in the thousandths place. Thousandths place. Left off my TH. Big difference. Thousandths place. Then you look at this number. This 0 here is in the hundredths place. Hundredths place is farther to the left, and so we're going to have to round to the hundredths place. That 9 tells us we round up, and so we report our answer as 9.41. Now, I do want to point out that it is possible to gain or lose counts of significant figures with addition and subtraction. So if we were going back and looking at counts of sig figs, this one has 1, 2, 3, 4, 5 count. This one has 1, 2, 3, and our answer has 1, 2, 3, 4, 5. If we look at this one, our first number has 1, 2, 3, 4 sig figs. This one only has 1 sig fig, yet our answer has 2 sig figs. And so if we were trying to base this off of counts, we would get our answer incorrect. So we are looking at decimal places, not counts. This one as well. This is 1, 2, 3, 4, 5 sig figs. This one has only 2 sig figs. Yet our answer has 3 counts of sig figs. And so with the addition and subtraction rule, the count of sig figs in your answer will not necessarily match your initial values. You do have to base your calculation on the counts, not the counts. You have to base it on the precision of your answer, not the counts. Let's see how those significant figure rules apply to a multi-step problem that involves mixed operations with addition and multiplication rules being applied. The first thing you need to do is just go ahead and calculate the full answer as if you were in a math class, not in a chemistry class with measured values that you have to worry about sig figs on. So you can go ahead and type into your calculator this full thing. Make sure you include the parentheses, and this is an implied multiplication in between here. So you can just type this all into your calculator, hit enter once, and you end up with 11.83363, and then even more digits past that. I just wrote ... to remind myself that there's more digits there. But this should be enough for us to figure out our sig figs once we figure out sig figs. After you get this number from your calculator output, you can go back and try to trace your sig figs through the calculation. As you're doing your sig fig rules, you have to remember to do your calculation in the order of operations. So We might remember the acronym PEMDAS from an algebra class that says, please excuse my dear Aunt Sally, with the P standing for parentheses. That means I have to evaluate what's in the parentheses first before I can do my multiplication. In order to add these two numbers together, I'm going to take this out of scientific notation. So 1.3 times 10 to the minus 2 is 0.013. So 12.01 plus 0.013 is 12.023. Based on my addition rule, I can see that this one is in the tens place, and that's the least precise. This is the hundreds, tenths. Gotta remember my THs, hundredths. And so this one needs to be in the tenths place, but I don't want to round yet because I'm not done with the calculation. We don't want to round yet because we don't want to end up with a rounding error in the end. You only want to round the final answer to a calculation. So at 0.98425 times 12.023. And I'm just going to underline that too so I remember that that's significant and that 3 is not significant. Now I apply my multiplication rule. The multiplication rule says that I need to keep the least number of significant figures. So that means I have to count my sig figs. This one has 1, 2, 3, 4, 5 sig figs. And this one has 1, 2, 3, 4 sig figs. I don't count to the 3. And so my answer here needs to have 4 significant figures. So if I go back to my original number, my calculator output, I can count off 1, 2, 3, 4 sig figs. And then I look one digit past that and I round down to 11.83. Next, we're going to talk about how we treat exact numbers in calculations. When we treat or do calculations with exact numbers, we have to remember that exact numbers have unlimited sig figs, essentially infinite precision, infinite counts of sig figs. So for example, if we were trying to figure out how many seconds are in 3.54 minutes, we can set up a unit conversion. And so we have 3.54 minutes. We need to cancel out our minutes, and we need to get into seconds. There are 60 seconds in 1 minute by definition. And so both the 60 and the 1 have infinity sig figs because these are exact numbers. Now we do our multiplication rule. 3.54 times 60 divided by 1 is 212.4 seconds. That's the calculator output. I do like to see the calculator output and then see you apply your sig fig rules. Also, if you have the calculator output and you've messed up on sig figs and you have that calculator output, you can go back and fix your rounded value without having to recalculate anything. So this 3 sig figs here, 3 is less than infinity. So 3 is less than infinity. Therefore, keep 3 sig figs. 1, 2, 3. So 3.54 minutes is going to be equal to 212 seconds. Here's one more practice problem for you. Go ahead and pause the video, and on your note paper, go ahead and work out these calculations, and when you're ready, unpause the video to double check your work. All right, let's go over this. So the first thing we're going to do is add our numbers together. And so the calculator output here is 161.145. But we have to figure out which is the least precise number. The least precise number is this one. That's only significant to the 10th place. And so our answer is going to be significant to the 10th place, which is, I typed something in wrong on my calculator. I know what I typed in wrong on my calculator. I typed in the first thing backwards. Instead of typing in 106, I typed in 160. So the calculator output should have been 107.145, but it's still significant to the 10th place. And so we take that 4 and we round down, and so that's 107.1. Now for our next one, we have 35.45 minus 30.5, which is 4.95. This is going to be the least precise, which is the 10th place. And so that's the 10th place. So we're going to look at the 5. We look at the 5, and then we have to round up so that this last retained digit is going to be even. And so that's going to be 5.0 milliliters. Now we'll take our next one. 50.5 times 12 is 606. This is multiplication rule, so this is 2 significant figures, which is less than 3 sig figs. So we need to keep 2 significant figures. And so we need to round up. Based on the 6, we round up, and so that becomes 610, which we could also report in scientific notation. As far as units go, I forgot to talk about units, but grams plus grams plus grams is grams. Milliliters minus milliliters is milliliters. Centimeters times centimeters is going to be centimeters squared. It's like x times x is x squared. And now we'll do our next one, which is 103.37 divided by 20.5. And our calculator output is 5.04234. Get these lines out of the way. And then our unit is going to be grams per milliliter. I'm going to have 3 sig figs in this number, 1, 2, 3, 4, 5 sig figs in this number. And so I'm going to need to keep 3. 1, 2, 3. So it's going to be 5.04 grams per milliliter. The 2 we round down. Sometimes it won't let me go to the next animation. All right, next up we got 10.001 minus 0.35. Got to evaluate what's in the parentheses first, and that's going to be 9.651. This is the least precise number, that's the 100th place, and so that 5 is the last significant figure in this calculation. Moving on to the next one, we're going to count this as 3 sig figs for our calculation for the multiplication and division rule. for our next step. This is 4 sig figs for the division rule. And then we will have 3 divided by 4, means that we're going to keep 3 sig figs. So 1.22 divided by 1.224, 7.88480. 1, 2, 3. So we're going to round down because the digit after the 8 is a 4. So we're going to round that down to 7.88. And then my final unit here is grams divided by grams, which is no unit at all. So that concludes our sig figs in calculations video. Let me know if you have any questions.